So today we're going to be looking at the complex solutions of cos theta, looking at these four examples here where a is greater than 1, so we're looking at the complex world. Cos theta equals a, cos theta equals minus a, cos theta equals ai, and cos theta equals minus ai. Now on the thumbnail to this video we put all of these arrows with a big question mark, but in actual fact we can see now. So this is the solution to cos theta equals a, this one is to cos theta equals minus a, this one cos theta equals ai, and this one to cos theta equals minus ai. And you can see there's a pattern there, and what we're going to do is we're going to do all four of them briefly so that we can get a real good understanding of cos theta in the complex world. Now, a couple of things before we start. First of all, there are always two solutions to these, just like there are in the real world when we have cos theta equals 1 over root 2 or whatever. There's two solutions in the first 2 pi. And also for general solutions, we just add 2 pi n to all of our answers. So I won't bother doing that, but that's what it is. Now, the final thing before we start, we did do a video on cos theta equals 3, which I'd advise people to watch if I go too fast in this video, because I'm not going to reinvent the wheel on that. So let's have a look. First of all, cos theta equals a. All right, well, cos theta equals a, and again, this is coming from this video that I've already done. We have that e to the I theta add e to the minus I theta over 2 equals a, i.e. we have e to the I theta minus 2a add e to the minus I theta equals 0, and that gives us a quadratic in e to the I theta squared minus 2a e to the I theta add 1 equals 0. Okay, now this will be the case for whenever we have cos theta equals a, where a is a real number greater than 1. All right, so now we're going to solve that. That's e to the I theta equals minus b, so that's 2a plus or minus the square root of b squared minus 4ac all over 2, and that simplifies to be a plus or minus root a squared minus 1. So this is the simpler one of the four. Okay, so therefore we can take logs, and that gives us that I theta equals log of a plus or minus root a squared minus 1, and therefore theta, just dividing by I, theta equals minus I log a plus or minus root a squared minus 1, and they are our two solutions. Remember, because a is always greater than the square root of a squared minus 1, we don't have any complications on this one like we will do later on, and so therefore these are our two solutions here. So as we can see here, that's one. Okay, so let's have a look at the second one now for cos theta equals minus a. All right, well, basically we go through exactly the same thing. We got that e to the I theta add e to the minus I theta over 2 equals minus a, and that gives us therefore, I won't bother going through the details, e to the I theta squared add 2a e to the I theta this time add 1 equals 0. Okay, so again, solving this by the quadratic equation, we get that e to the I theta equals minus b plus or minus the square root of b squared minus 4ac all over 2a, which gives us minus a plus or minus root a squared minus 1. Okay, so here's where we get a little bit more tricky. So taking logs, we now get I theta is equal to log of minus a plus or minus root a squared minus 1, and that equals log of minus 1 add log of a plus or minus root a squared minus 1. What we've done is we've taken the 1 out of there. Okay, so now we have to work out what the log of minus 1 is. Well, if we just look at a quick argon diagram here is minus 1, so that is pi. So minus 1 is e to the I pi, so therefore the log of minus 1 is I pi. So we can write in here I theta equals I pi add log a plus or minus root a squared minus 1, and again dividing by I, we get that theta equals pi minus, I log a plus or minus root a squared minus 1. And that is the answer for cos theta equals minus a. And you can see that, again, we have our two solutions here. Okay, so now we're getting a little bit more complicated now. Let's have a look at cos theta equals AI. All right, well, again, we go through the same thing. E to the I theta add e to the minus I theta over 2 equals AI, i.e. e to the I theta minus 2AI add e to the minus I theta equals 0. So again, we get our quadratic, e to the I theta squared minus 2ai e to the I theta add 1 equals 0. Solving that with our quadratic formula again, now we have to be a little bit careful here. So minus b, this is b here, is 2ai plus or minus the square root of, now b squared, we have to be very careful, is minus 4a squared, because I squared is minus 1 and minus times minus is a plus, so it's minus 4a squared minus 4 over 2, which equals ai plus or minus I, taking the I out, root a squared plus 1. So now we have to be careful here because we have to split. Let's just take the I out here. No, I'm not going to take the I out yet, sorry. So we have to split this into 2, and the reason will become evident in a second. Let's just go on to the next page here. Okay, sorry about that. Okay, so we need to split. So e to the I theta equals either I, we're taking the plus and minus of this separately, either I, a plus root a squared plus 1, and the second solution is e to the I theta equals minus I minus a add root a squared add 1. And the reason we have to split it like that is because otherwise the a squared plus 1 minus a, or minus a add a squared minus 1, will be negative. So we have to just split it like this, and that gives us two solutions here. Basically, I theta equals, just taking logs, log of I add log of a plus root a squared plus 1. That's that one. Or, I theta equals log of minus I plus log a add root a squared add 1. Now looking at, again, at the argon diagram, here is I and here is minus I. Well, that's pi over 2, and that's 3 pi over 2. So I is e to the I pi over 2, and minus I is e to the I 3 pi over 2. So therefore the log of I is I pi over 2, and the log of minus I is I 3 pi over 2. So that gives us that I theta equals I pi over 2 plus log a add root a squared add 1, and I theta equals 3i pi over 2 add log a add root a squared add 1, and then just dividing by theta, we get that theta therefore equals pi over 2 minus I log a add root a squared add 1, and theta equals 3 pi over 2 minus I log minus I, I'm sorry, I've just gone wrong tiny bit here. That is a minus in there. My apologies, I've gone a bit too quick. There's a minus in there, isn't there? So there's a minus in there, which means there's a minus in here, add root a squared add 1. So these here are our two solutions to cos of theta equals AI. Let me just check I haven't got that wrong, because this is important, obviously. Or 3 pi over 2 minus I log. Yes, that's correct, right? Okay, now finally, fourthly, we have cos of theta equals minus AI. So we get the, basically it's the same as the other one, but we get e to the I theta squared add 2ai e to the I theta add 1 equals 0, i.e. e to the I theta now is slightly different. It's minus 2ai plus or minus root minus 4a squared minus 4 over 2, which equals minus ai plus or minus I root a squared plus 1. And again, we have to split here into 2. So we've either got e to the I theta equals, taking the minus I out, a add root a squared plus 1, and e to the I theta equals, taking the I out this time, minus a add root a squared add 1. And then when we take logs, we get that I theta equals log of minus I add log a add root a squared add 1. That's from this one. Or, and I theta equals log of I add log of minus a add root a squared add 1. And so that basically, now dividing by theta and just converting the two logs that we've already done previously, we get that theta, this one here, is theta equals 3 pi over 2 minus I log a add root a squared add 1. That's one solution, and the other solution is theta equals pi over 2 minus I log minus a add root a squared plus 1. That's the other solution. Okay, so those two there are the solution to cos theta equals minus ai. These two here are the solution to cos theta equals ai. And then where were the solutions to... here are the... Oh, no, not there, sorry. That's cos ai. And then we got here are the solutions, my apologies, here are the solutions to cos theta equals minus a, and then finally here, the easiest one here is the solution to cos theta equals a. And you can see that in actual fact, once you understand why we're getting this pi and the pi over 2 and the 3 pi over 2, this bit here is always relatively similar. It's always minus I log of, if it's a real, a plus or minus root a squared minus 1, and if it's complex, a plus or minus root a squared plus 1. Well, I hope you found this useful, because certainly what it does is when you do find something like this, you can instantly recognise which type of cos theta it is. If you found this useful, please like it by pressing the little thumbs up button, which takes about 1 second, and subscribe to the Aggressive Academy YouTube channel. Thank you.